Hello, Vivek. You are a co founder at Cursive at the intersection of crypto and design. And Cursive uses cryptography to discover and deepen human connection. Do you want to start with telling us a little bit more about your journey in cryptography and what brought you to founding Cursive?
Yeah, totally. So my first work in cryptography was actually around 2016. I was lucky enough to be part of a research program at MIT for computer science students, and I was just randomly slotted into cryptography because like one of the professors in the program, that was their focus area. And yeah, like started out doing some alternative consensus protocols like proof of space, in contrast to proof of work, which is the primary thing at the time, which is very cryptographic. It was like basically Merkleizing different and stuff, using some really old research to try to figure out how we could build a consensus protocol around that. And then in 2017, 2018, I was doing work that's a lot closer to ZK land, which is basically using KZG polynomial commitments to build authenticated dictionaries. Basically, like databases where you can make proofs about membership and non-membership and prove that it hasn't been sort of maliciously messed with, essentially.
Mhm.
And then I was like, wow, this stuff is so cool. Like I want to keep doing this. But I didn't want to be an academic. I figured that out pretty quickly. And it seemed like industry at the time for cryptography was like cryptocurrency. And at the time, it just seemed like a bunch of like financial scams and like just like gambling, basically. Maybe it still kind of is, but even more so then. And like, I was like, okay, I guess there isn't really a space for me. Like, that's sad, but I'll do other things. And took a break for a few years. And then in 2021, got reintroduced to cryptography through my friend Ayush, who's also the head of ZK Email now. And he was basically telling me about his friend Brian, who's the founder of 0xPark, and how
Mhm.
they were basically spinning up a lab to work on zero knowledge cryptography, which I'd never heard of. And yeah, I looked into it a bit more and I was like, oh shit, this is like the same cryptography that I was working on in like 2018, 2019, just in a very different context. And so yeah, started to get grants from 0xPark to work on various CK apps. So I guess that's how I got into ZK land. And then Cursive was founded basically, I would say in Zuzulu in like
Mhm.
2023. Zuzulu is like a pop-up city with a big focus on cryptography and cryptocurrency, as well as like biotech and neurotech and a bunch of other things. And I met like one of the co-founders, Rachel, at this event, and we discovered that we had really similar interests around like trying to make cryptography more easier for people to understand, especially who are outside of the space. And we collaborated on some initial kind of physical cryptography NFC experiments there. So
Mhm.
yeah, it wasn't called cursive then, but that was kind of the first few like cursive related experiments. And then we met Andrew in that summer, like August 2023. And then as a group, we've been working on projects ever since then.
Cool. Excellent. Yeah, and talking about physical cryptography in a sense. The first time we met, the Hyli and Cursive teams, was at ZK Summit 12 in Lisbon, where you had those physical cards with NFC, which were really cool because you could just like scan other people, and it had two main uses, one of them being building your network simply because people could set up profiles with their social media and so on, which is cool in itself. But it also had all those crypto enabled features with multi-party computation mostly, I believe, and several different applications that you just put all on one card. And I'd love for you to talk a little bit more about that and tell me, did the idea come from, hey, we need to make cryptography physical, or did it come from, oh, we need cards of some kind, and then coming to, hey, let's put cool stuff on them, or the other way around? What what was the process behind that? And first of all, how did it work?
Yes. So how it worked was basically like you described it really well. So like there's two main elements. There's like one which is the NFC card,
Mhm.
and basically that's a way for you to build an in-person social graph. And like also it allows you to collect some like ZK friendly data. So each person you meet, you basically receive a unique baby jub jub signature from them. And, as you meet more and more people, you collect more of these, and now you have this like set of signatures to make proofs about. And the main proof you could make here is just like, oh, I have X number of taps or something. So you can basically claim some prize. And then the other side of it was, with this basically in-person social graph, you can also start to experiment with like features that involve multiple people. So in this case, we were experimenting with like a 2PC or two-party computation where you could essentially, after you meet somebody, one thing you can do in the app is you can basically attest to a variety of hot takes on cryptography. Like if you thought someone was like underrated or overrated, and we came up with some list of like 10 things. And what you could do is when you meet somebody, you can basically discover, do you guys think the same about a specific topic? Do you both think it's underrated? Do you both think it's overrated? As basically a way to quickly meet somebody and get a lot of shared context. And I think this relates a lot more to like the general mission of using this stuff to help people connect more easily. NFC as well, and the ZK allows you to own your social graph and make it portable, but this was much closer to like, oh, I learned a bunch of things about you.
Yeah.
And then in terms of process, this was, I think, much more technology first in a process. A lot of it was like, okay, we like ZK, but one thing we need for ZK is data that you can make proofs about. How are we going to do that? One thing you can do is you can give people NFC cards and you can at least digitize the people they're meeting, the places they're going to. And then the MPC, maybe actually that was less tech first. It was again around basically now we have interesting data between two different people, like people you've met or things you're attesting to. Like, how can we use this in a way that allows people to be more expressive, more vulnerable, more like honest with each other? So I think that was maybe working a bit from a vision of like, oh, we should be able to connect more easily, and then using cryptography as a tool for that. But yeah, I'd say overall the ethos has definitely been in 2024 more technology first and more like R&D focused, where it's like we have this technology, we want to figure out ways to use it, and we also want to figure out like what are the bottlenecks in terms of deployment,
Mhm.
so we can kind of solve that with research or design.
Yeah, and one of the bottlenecks that you have seen is something that we also see, which is a lack of data to prove in the first place, then I
Yeah.
suppose. Have there been other main bottlenecks that you've seen, or should we start talking about the lack of data?
Other bottlenecks, I mean, a lot of it is just like computation stuff. A lot of these computations take some time, whether it be doing the cryptography itself. When you get to MPC land, there's another interesting thing of bandwidth and back and forth communication. So generally how a lot of these protocols proceed is that there's many messages sent back and forth between the two or more parties. And it also generally scales the more and more parties you add. Um, like or scales like quadratically. And so, yeah, there's kind of a lot of things to think about there. And I think later in the chat, we'll get to some of the solutions we had for this. But, and then, speaking of a lack of data, other solutions we've explored for this are using the email to like import a
Mhm.
bunch of things. We've played around a little bit with like zkTLS. Um, More so far, I've just used like OAuth, log in with Spotify and import a bunch of data. Like
Yeah,
it's not verified, which is like fine in a lot of cases.
yeah, because imperfect data is still better than no data at all to work on, I suppose.
Absolutely. And like when you get to, especially in the use cases that we're thinking about around connection, there's kind of an effect where it's like, well, there's two sides of it. One is like, I want to import meaningful, honest data so I can get more interesting like matches or connection or synergies. The other side of it is that you can just lie that you're interested in like everything and then you can sort of
Yeah,
match with everybody. So it's just a balance for whichever situation you're in. If you think people will be more adversarial, then you really need more verifiability, which like a ZK and signatures are perfect for. But if not, it's usually a lot easier and a better UX to just like import some data and use it.
yeah, it comes back to a certain vision of trustlessness, where it's like when it comes to trusting each other in terms of not in terms of trustlessness, but in terms of human connections, of
Right.
trust as a human relationship context, then we can assume good intent in most cases because there is an incentive to be truthful about yourself because you're going to get matches that are interesting and you're not going to match with people you just don't like, which is something that we see
Absolutely.
a lot in social tech. Yeah. We talked about it, for example, with David from Playment, and we were saying for gaming, you don't need perfect trustlessness if you're playing with your friends. And
Yeah.
yeah, it's pretty much where it comes back to here.
Absolutely. It's also very related to trust infrastructure, like the set of essays from Arnaud, who I know you guys have worked a bunch with. Like there was like an event at ETCC that I am very sad I wasn't able to go to. Looked great, but yeah, I definitely align with that thesis a lot in that I don't think trustlessness is actually a, a desirable quality. I think building infrastructure that enables for more trust and more kind of like safety between people is a lot more valuable to me. Because yeah, I think trust is super valuable. And like I think there's some situations in which we should maybe not need to trust a specific third party, but in situations where you're, yeah, like with friends or playing games, it's like, no, like we can like sort of lean on each other more and it's good for connection.
Yeah. Yeah, it's just be chill. Let's just have a nice
Yeah.
time and let's just assume everyone wants to have a nice time. Sometimes it's
I,
just worth it. Coming back to the more technological part of it, as you said earlier, we did have time to discuss MPC and difficulties and bottlenecks. And I wanted to come back to those very quickly. So you saw MPC, multi-party computation, and it was exciting. And as you said, it was more about research and development in 2024. And I'm wondering, yeah, what did you see? So outside of this zkTLS, zk email, and tested data that is not verified, outside of that, what other either workarounds or full-on solutions did you see to our current cryptography blockers?
I'd say problems with like computation and bandwidth with something called multi-party FHE or threshold FHE. So it's a lot of jargon, so I'll try to break everything down. FHE is fully homomorphic encryption, basically means like I can take some piece of data, I can encrypt it in a sort of like structured way, and I can send this to a server that can run some operation on it. The entire time it remains encrypted, so the server doesn't learn anything. And then when they send sort of the final result of that computation back to me and I decrypt it, it's as if they did that same operation on the plain text data. The canonical example here is usually around like medical stuff. So maybe I encrypt like my DNA. I don't want like a server to know my entire like DNA sequence necessarily. And so I do that. They run some operations on it to see if I'm at risk for any sort of specific diseases or if also like I have some like benefits or other things. All the while this remains encrypted. And then when they send that back to me at the end, when I decrypt it, I can see all these results. And so I can basically learn about the output of this without them learning things about me that I don't want them to.
Yeah.
And so this is the way I described it, a very like single party kind of application. But what you can do here is you can make this encryption step into an MPC. So let's say between you and I, like we want to, yeah, let's say discover commonalities. And so what we do is we engage in an initial multi-party computation to generate a shared public key.
Mhm.
So how this works is essentially like we don't, neither of us know the corresponding private key, but we
Mhm.
both basically have generated a shared public key that is basically like we each know like half of the private key too. And so once we have this, we can both like fully homomorphically encrypt our data to this public key. We can do some computation over it, or like a server can do some computation for us over our data. And then once the server is done, it can send the result back to us, and then we engage in a final MPC to decrypt. And so this seems like, like why all these steps? Like what is the benefits here? The main benefits here is that like the users are only responsible for encrypting and decrypting the data, which tend to be very light operations generally. And you can offload the actual computation completely to the server. And so basically, it's nice in that, yeah, the user doesn't have to do much work, and the number of back and forth rounds is generally a lot lower than traditional MPC schemes because in a sense, like the server is kind of handling a lot of the work itself in a way that's privacy preserving. Um, I think the final thing I'd add is that in general, FHE is very expensive. Like you incur lots of costs to be able to do this, but one really nice thing is that you can basically throw this problem at a really boosted server, whether it has a bunch of GPUs or other compute, and so you can make the overall UX really good. And so I bring this up just basically to answer like, yeah, this is one kind of really clever technique to improve like various parts of an MPC. And also a big shout out to John Majaya of Gauss Labs, who was basically the research mind behind this, and we collaborated closely to like get this across the finish line. It was very tricky and weird, and it was a bunch of new code that a lot of people haven't messed around with, but his support was invaluable in getting it across the line.
Sounds like very classic cryptography then.
Yeah,
All
definitely.
right. Is this linked to Trinity, so the novel cryptographic system that you introduced at ZK Summit 12 in your talk? Vivek?
Yes, it's super related.
Yes.
Trinity is another kind of solution to a bunch of different problems we identified, and actually, like, it's what we're going to be using moving forward instead of multi-party FHE. So there's maybe two main kind of drawbacks of multi-party FHE. The first is that there actually it, you reduce the number of rounds of interaction a lot, but there's still about four because you need to also interact with the server. You need to wait for the server to finish the computation. Um, and the problem is this makes for really weird UXs, especially with like consumer apps, because the short answer is that people just put away their phones, which means that their phone can no longer receive messages and send messages as easily. And so this means minimizing the number of rounds makes for just like way simpler UX and also a developer experience. And that you don't need to really think about like, yeah, tracking all these rounds and like building UXs and screens around explaining this to users. And the other unfortunate thing is that to be able to prove like authenticity of the data that's involved in the computations here, it's a fairly expensive process with FHE. There's some amazing work out of PSC called Greco, which was built by one of their devs, Enrico, actually does answer this. It basically builds a way to have verifiable data inputs into an FHE computation, but it is expensive. It's like a lot of extra work you incur. And so, yeah, Trinity is a way of solving both of these, where it gives both a one round protocol, where essentially, like, if me and you are engaging in a 2PC, like, I just need to send you one message, and then you can basically do some computation on your end, and then whatever result you get, you can act on. You can send it back to me, you can like make some other action based on that, and there isn't any other kind of back and forth. And then the other nice thing is that it pairs really nicely with existing zero knowledge schemes, especially like KZG based ones like Plonk, to have really like efficient data verifiability in a way that doesn't incur a lot of extra costs. As far as I can tell, like just from some conversations with NPC researchers, it's a fairly unique set of trade-offs, especially around data verifiability, because that's, I think, not as much of a focus in a lot of this existing literature. So yeah, that's kind of how Trinity works.
Okay, that's very interesting. Why do you think it's not that much of a focus in existing literature?
My guess is that generally how they think about it is like if you want to verify some claim, let's say like for example, a passport proof, like you want to
Mhm.
prove that I'm from the US or something, you can actually just do all of this inside of the MPC. Like it can just be one of the computation steps you're doing is like verify the RSA signature,
Mhm.
extract the fact that I'm from the US or something. And it's like it can theoretically be done in the MPC. It's just a huge blow up in terms of
Mhm.
computation cost. But I guess like separating these things out maybe has not been as much of a concern. If anyone's watching this and knows of a lot of great work in this region, like please let me know. I would love to like know of more efforts in this direction. I'm looking to learn here.
All right, well, if someone has more insight, our comment section is open. All right, moving a bit more from the technology itself to I think the philosophy that goes under it with everything you work on, you've been saying a lot that, especially the cards, so those physical cards at the beginning that we talked about, are a way to educate people about cryptography through fun experiences. So, what made you want to make them accessible and understandable, where when it might not actually be needed to understand them to use them?
Yeah, it's a great question. The short answer is just like an intuition, where I think if people don't have an appreciation or at least like a high level understanding of what technology is being used, like it's pretty easy to equate, making a ZK proof to just like trusting Google to do the right thing with your data. And that both of them boil down to like, oh, I'm trusting some smart people to do the right thing. Even with ZK proofs, there's people who are writing the circuits, there's people who are auditing them, there's people who are deploying them. All of these are places for errors to happen. And ultimately, you are just trusting people at the end of the day. People like saying, oh, it's all just math, which is true to some extent, but it is to the average person, the math is meaningless. It's so you are just trusting some smart people to do the right thing. I feel strongly that if there isn't some awareness of this technology and like what it's doing and how it's different,
Mhm.
then you might as well just do the other version because it doesn't change the user experience meaningfully. At the same time, it's worth also balancing with the fact that the most successful deployments of cryptography have been very under the hood, like TLS being the best example of like you just have that little lock icon on your browser and you know you're safe. Underneath the hood is like a lot of really great cryptography going on, but consumers don't necessarily like know or appreciate this. And yeah, then maybe how I'd respond to that is like instead what it is just like making good interfaces and
Mhm.
explanations and protections for people, even if they don't get the stuff below. But yeah, it's mostly an intuition and also kind of just an interest in education. And I think this stuff is really beautiful and I want more people to know about it.
As you said, it's like, oh, it's moon math, but also if we say that it's easy, then then we're lying. And if we say that it's hard, then there is this risk of disengaging people because they'll just be like, as you said, oh, engineers are smart, they'll just do the thing for me. And then they won't check it. And there is this thing where trustlessness is something that only happens today. Every time we talk about trustlessness, what we're actually talking about is people trusting the blockchain or whatever to be trustless because they don't know
Right.
how it actually works. And yeah, it's really general education. Teaching people about decentralization was the same, still is the same. And you've done this in very different formats. And one thing that I unfortunately never went to, but I'm hoping to see it in person someday. At a couple of events, you did this cryptography museum exhibition that I thought looked absolutely amazing. And obviously, yeah, I haven't seen one, but I really want to see one. Um, is this again just this intuition and this just I want to share something about cryptography? Do you think there was more of a narrative behind it of let's see where it brings? I'd love to know more about those exhibitions.
Yeah, definitely. Well, first off, like we're gonna have some really good video documentation of it coming out soon, so you'll get to experience parts of it and different exhibits and artists. But yeah, like the overall concept that we did here was this like cryptographic connections museum where it
Mm-hmm.
was a booth right at the entrance of DevCon. Shout out to the DevCon team, gave us an amazing opportunity there. And the goal was basically like to explore cryptography for connection is a big part of our team's thesis. And the museum's goal was to basically try to figure out like, yeah, can we just kind of demonstrate this power of cryptography to connect people, both in terms of historical examples. Stuff like encryption and signatures are amazing ways to connect securely. Were so useful in different periods of history. In present ways, like sort of like what teams are currently working on the ecosystem, can we give them a spotlight? Can they make some sort of demo or some sort of art piece about what they're doing? And then also kind of like more future facing and abstract representations of this technology as well. We were lucky enough to be part of this pop-up city called Edge City Lana that had
Mm-hmm.
many artists in-house. And so we just collaborated with a bunch of them to basically come up with concepts for, yeah, how would you basically like explain or explore what cryptography means? And yeah, the kind of overall goal, just being like, educating people on this technology, getting them excited about it, and also like sort of putting an artistic flair on a field that tends to be very like math and technology and like a little bit pretentious at times, of just like purists on certain things, but trying to be a bit more like colorful and exploratory. And yeah, like I think it was a great success. Like it was just fun to highlight so many of our friends doing amazing work and like give them a spot to do a demo like right near the front of the venue. A lot of people came by and were just like, I think were able to really appreciate cryptography in a different way after just looking at some art pieces and some kind of alternative ways of like explaining its power. And yeah, it was super fun. I hope we get to do something like that again. But if not, like it's I think a really good artifact that I would love more people to like learn about and see.
Yeah. Well, I'm glad we're gonna have videos. I can't wait to watch them. Let's say all of your experiments are absolutely working, and someone sees all of this and thinks, okay, cryptography is interesting. I want to get into this. I'm curious. I want to know more. It's still very daunting. There is still this one giant step between being interested in the concept and stepping into it. Do you have any advice that you would give someone who's curious about entering that space and starting from scratch?
Yeah, definitely. Like, I mean, it depends on your background. Like, I think if you're a math person, which I definitely was entering the space, it's really fun to just like learn about what's going on underneath. Like some of these cryptographic protocols are just like so beautiful. Like everything just like clicks together really well. And you can build these really powerful systems from, you know, a single cryptographic assumption. You can make stuff like zero knowledge proofs and fully homomorphic encryption. So the math is amazing. I think Vitalik's blog is an amazing resource for like what I kind of call like medium level articles. Like I feel like
Mm,
it's really hard to find stuff that isn't like so simple you don't get anything from it, but also so complicated that it's difficult to dive into. And Vitalik consistently strikes a balance between the two of them that is like both really hard to do and really appreciated by me and lots of other people. His resources are good. Justin Taylor has an amazing textbook on this stuff.
mm,
Xerox PARC has a lot of amazing learning materials, which is where I learned how to code and zero knowledge stuff. So yeah, I'd recommend just trying to dig in a little bit to the math. If you don't have a math background or it's not something that excites you, like I would say you don't need to know it to really be able to do good stuff. With stuff like SP1 and these Rust CKVMs, it's easier than ever to develop with this technology, and just sort of have all the cryptography stuff handled in the background. So
mm,
I'd recommend giving that a spin. I've had a great time using SP1, good friends with the founders. I think they're doing good stuff. And there's a lot of other options too, like Risk Zero and others that I'm forgetting. And then I think if you don't have like a technical background, I think there's lots of opportunities to be able to think really like rigorously about
mm,
where and why this technology should be used from a design lens, from a communications lens, from a product lens. I think that's probably the biggest gap in the space right now is just more people thinking about it holistically and building really
yeah.
good overall tools and products for it. So
Mm,
yeah, there's lots of stuff to do here. And also feel free to reach out to me whenever if you want more specific guides or resources. I'm happy to help.
mm. Where would people reach out to you if they were interested and had specific questions that they would like to ask you?
Twitter is probably best. Like I am Viv underscore boop, BOOP. Um, and also Cursive has a Telegram group that you can join. That's pretty good. Just to ask questions or like you can find me and the rest of the team there. Yeah, those are probably the best places.
Well, you also have a blog, and on this blog, you've written, it was a while ago now, but it's still a staple article, in my opinion, about signed exchanges and how they're used, so SGX. And what, in general, what would you say is your vision? Like, how do you imagine the future of digital signatures and just owning your own data and what you do on the internet? Like, yeah, having control of what you do and how it's treated.
Yeah, I'm just excited for a world in which like this stuff is like all of your data across different sites and everything you're doing and visiting is like signed and owned by you. Because I think there's probably two main trends that I think are interesting here for this. The first is just like general portability of data, like being able to switch between experiences more freely. Like Twitter sucks in a bunch of ways right now. It's just a lot worse than it was like even a few years ago. I think that's a fairly consensus opinion, but like, still 100 million people pull up or whatever it is, whatever their DAU or MAU is, like, and I still use it despite like, it just being a terrible experience in a handful of ways. And I think we're well past a time where we have the technology to be able to quickly move between platforms.
Yeah.
It's just like network effects are really strong, data lock-in is really strong, algorithmic lock-in is really strong, and ways for that to become more flexible, I think are going to be amazing. The second trend, which I think is approaching faster, or at least is easier to act on, is like personal AI assistants. I think are going to become a ubiquitous part of life for many people, and giving them access to the full context of who you are, as well as like verifiability on various things as it's needed, I think will be super helpful for these agents to be maximally useful to us and
Yeah.
grounded in who we are. So I think that will also accelerate this trend of just exporting more data, getting it all in one place. In that world, signatures matters less because it's like a personal agent doing stuff for you. It relates to things we were talking about earlier of like you don't benefit from lying to your agent in a bunch of ways. Like you might as well just be yourself and let it help you. But signatures could be useful. And if your agent wants to go and, I don't know, get a loan for you or something, maybe it needs
Yeah.
to have some signatures on your credit score and like your, salary, or where you live, stuff like that.
Yeah, it would
So
still need information that you don't want floating around on the internet, or that you don't want anyone to be able to give pretending to be you, even though obviously giving fake information to your agent would just it would only hurt you. Yeah,
like,
there's still some incentive there to have those signatures, and not to protect you from the agent, but to help the agent perform actions on your behalf then. Yeah.
exactly. Yep.
So on one hand, you have this approach with AI, which is more on the future of this data, really, and on the other hand, you have data ownership, portability, and just being able to just move from one platform to the other and just find your information there and be able to just move as seamlessly as possible. And in practice, how do you imagine that?
Yeah, it's a great question. I think we haven't quite figured out the right UX for this sort of thing. I think password managers are basically the closest we have to something like this, where in a sense, like they're basically storing like your encryption keys. Not
Yeah.
really. It's like your passwords to log into your account and then it's just sitting on the
Mm.
server in plain text. But like this is this big bucket of basically connecting all your different accounts. So I think some iteration of that like makes the most sense to me, at least as like an initial version. And then I also have a theory that if this stuff ever gets used enough or there's enough sort of like standards around, like Apple, Google, Windows, like they will build some like OS level version of this. Like, you can already see this with some iCloud stuff. Like there's some really nice integrations that Apple does, and
Mm.
even like Apple Wallet, for example, is like some proto version of this. And I think there will be some sort of like OS level like data bucket or backpack or whatever you want to call it that is super easy for like websites to access, and there's some standardized API for them to do such a thing.
Mm.
Ideally, everything has zero knowledge proofs, but it's pretty easy to go in the other direction. Like you can even see with like, I actually haven't used it myself, so again, might be wrong, but I understand that Apple basically has your licenses now. Like you can put your licenses, driver's licenses in Apple and Google Wallet. And I think they have some sort of ability to be able to prove you are above a certain age. And I think this is just like a trusted attestation from Apple, roughly.
Mm.
Which is like fine. I don't know. Like that's the cryptographer in me is like, no, like use ZK. But
Yeah.
for application developers and for users, like it's looking that's pretty good. Like I trust Apple with everything. Like I'm down to trust them with making the right signature here.
Yeah.
So I do
Yeah,
kind of see that being the direction.
and we come back to convenience versus being perfect.
Exactly.
Purity versus actually using the tools.
Exactly. Yeah.
All right. I think our interview is coming to an end very soon. And I was wondering if you'd like to close on really anything you want to share. So, this is usually the moment that people take, either for a call to action. It can be about, like yourself, about the project, or just talking about something that you care about, your vision for the future of the industry or the world, more philosophical, anything you'd like us to just remember and think about. In the weeks to come, of just, yeah, if we can just sit down and think of one thing or do one thing, what do you think? What would you like to share?
Yeah. I think like in terms of future facing products, like Cursive is still finalizing that. So not a lot of concrete things to share, but expect to see some things the next few months. Um, so yeah, I guess I'll go a bit more philosophical. Something that I've been thinking a lot about is like ultimately what a lot of this technology is working towards is giving people a sense of safety, whether that be safety in terms of privacy or in terms of portability, that I can take this stuff and move it somewhere else, or in terms of being able to share exactly what I want to share, like selective disclosure. And I would really push people to think hard about this concept and understand that for the average person, the technology is not what's going to make them feel safer.
Mm,
I think the best example of this is like LLMs, like ChatGPT, like people love to use as their therapist, including myself. Like I'm a Claude fan myself, so like I just told Claude like a bunch of random things about my life that I probably would not have felt comfortable telling a lot of other tools and technologies, but something about getting this like empathetic, thoughtful response, having it be conversational, there's a feeling there. And I feel safe, even though I know it's just going in plain text to their GPUs. And so I would really push developers and builders in the space to like kind of step away from like purity a little bit in terms of like, oh, what do you think Vitalik would like the most? What do you think is the ideal system for cryptographers? And think really hard about the feeling of your application, which mostly will come down to design, product, and comms, like the writing you put inside the app.
mm,
And I think just having more of an emphasis on that than the technology, because I think technology is important insofar as you can guarantee the user a certain level of security and strength. But past that, like, it doesn't really matter. Like, if they don't have a deeper appreciation for what's going on, which also to be clear is not like like, consumers like need to get smarter or need to be better at math or something. Like it's completely reasonable for people to not understand how everything works. I barely know how a computer works and I love using it. It's just like we need to appreciate where people are currently at and
mm,
I think build for that. So that's one philosophical rant of sorts. There's one other thing that came to mind. Oh, yeah, I think people are underrating self-attested data too much. We talked about it a bunch in this call, but I don't think you need a signature on everything. I think there's lots of situations in which you don't, and lots of situations in which it makes everything way easier to do.
mhm,
So I would just think, like, ask people to think really hard about this. Like, don't default to requiring zero knowledge proofs and signatures in your stack. Like, it's often fine to do something weaker, especially for MVPs. And then maybe the final thing I'd say is I think secure hardware gets a bad rap in the space, but like I think if it is a way for people to more easily prototype ideas and get something to people with good UX, we should do it. And we should
mm,
validate that these things are important first before investing like, millions of dollars into cryptography research for it.
mhm,
Just because I think I mean, it's amazing all the like research that's happening right now, but it would be so sad if it just is useless. And like, I think we could do a much better job as a space of like validating that certain things are important, that people actually need the cryptography behind a certain thing before we build everything out. Your hardware is a good tool there. Also, like just not using anything is a good tool. Like just telling the user, like, we won't sell your data. Like, is that enough? If it is, like, I don't know, should we be doing all this stuff? Yeah, maybe to just summarize, like, I would love to see people just thinking more critically, asking hard questions about how necessary different parts of the toolkit are,
Mhm.
and doing some A/B tests, just like trying one thing, trying another, seeing how people react.
Yeah. And keep thinking about building for empathy and comfort and not just very cold and solid blocks everywhere.
Absolutely. No,
Yeah.
that's a
Keep
great way
some
of
doors
putting
open.
it.
Well, those are beautiful words to end the interview. So thank you very much.